Have you ever wondered how people send emails or files that only one specific person can read? Not HTTPS secure, but person-to-person secure. That's where OpenPGP and GPG come in. And in the next 5 minutes, I'll explain exactly how they work, why they exist, and when you should actually use them. First, let's clear up the confusion. OpenPGP is a standard, not a tool. It defines how encryption, signing, keys, and trust should work for secure communication. Think of OpenPGP like HTTP. It is just a rulebook. Tools like GPG are implementations of that rulebook. It uses a public key for encryption and a private key for decryption, allowing users to securely exchange sensitive information. It also allows to verify sender's identity and check for tampering. PGP, Pretty Good Privacy, is the original proprietary software that is used for encrypting and signing data. It implements the OpenPGP standard. Phil Zimmermann created the first version of PGP encryption in 1991. In February 1993, Zimmermann came under criminal investigation because of PGP. To know more, you can visit Wikipedia page of PGP. Initially, his company PGP Inc. owned this software, but then Symantec acquired PGP Inc. and then it was acquired by Broadcom. So basically it is not free, and these days people moved out to free and open source versions of it. GPG or GNU Privacy Guard is the most popular OpenPGP implementation. It's what you actually install and use on your machine. With GPG, you can encrypt files and messages, digitally sign content, verify who really sent something, all using strong proven cryptography. Let's see how to do it. For most of the Linux distros, GnuPG comes pre-installed. To install manually, you can use apt for Debian-based Linux distros, yum for Fedora, and pacman for Arch Linux. For macOS, it does not come pre-installed, so you need to install using your package manager of choice. Just for this purpose, I am going to spin up a Docker container with Ubuntu image. I also need shell access to it, so I am gonna run it in interactive mode. Now let's install GPG in the machine. For this, we need to update the registry and run install command. Let's encrypt a secret file which I already have in my home directory. But for this, we need to have public key of the recipient. In real scenario, receiver usually share their public key to a sharing platform instead of sending individually. I will tell you more about this at the end of this video. Just for this demo, let's create a key pair for the receiver. To do this, we need to run GPG with full generate key option. This will ask you the key owner's name, email address, encryption algorithm, validity duration, and a strong passphrase. You can use default values by pressing enter. Passphrase protects confidentiality even if your private key is stolen. Keep in mind that it is recommended to keep a longer passphrase for better security. While GPG is generating keys, I suggest you to move your mouse, type something on your keyboard or any other activity, because it needs to generate a large number of random bytes, and this will give it enough entropy. The key pair is generated. Let's list them out. Here you can see the public key's fingerprint only. Let's encrypt the secret file. For this, we need to pass encrypt option with recipient email address. This will generate a encrypted file called secret.txt.gpg. You will not be able to read the original content from this file. Imagine that the receiver is willing to read this file. Let's decrypt it. You need to understand that the file already has all the necessary information about the receiver. So the command only takes the file as argument. It tries to find the necessary private key in the keychain. In our case, the keys are already in the keychain. Encryption is only half the story. OpenPGP also supports digital signatures. When I sign a message with my private key, anyone can verify it using my public key and know the message wasn't modified and it was really sent by me. This is how OpenPGP builds trust, not through central authorities but through something called the Web of Trust. Here is a demo. Here I have a dummy JavaScript code I downloaded from the internet. The publisher signed it with their private key, and to check its integrity and authenticity, I'm verifying it using their public key. First, let's sign the document using my private key. We can see that a separate signature file is created. Now the publisher will publish the original file along with the signature file in their website. But sometimes we download the code from third-party websites and want to verify using signature published by the original author in their website. After downloading both files, we verify the content with signature. We can see good signature message in the output, which means the file is safe. Yay! So where is GPG actually used? It is used in secure email communication, signing Git commits and releases, encrypting backups and sensitive files, verifying software authenticity. If you care about privacy, integrity, or identity, GPG shows up everywhere. For exchanging encrypted messages, emails, or files with second party, you need to share public keys. You can then ask them to go to the key hosting site and search for the public keys. A proper way to share a public key is to upload to a different host like openpgp.org, mailvelop.com, and OpenPGP key server. To summarize, OpenPGP is the standard, GPG is the tool, public keys encrypt and private keys decrypt and sign. If this video helped you to understand OpenPGP, GPG and PGP, like the video, subscribe, and I'll see you in the next one.